In this video we're going to look at simultaneous equations, and we're going to look at the method for solving them called the elimination method. Now there's the other method called the substitution method, which you can see in the other video, but here I'll show the elimination one. Your preference as to which one you choose to use, they will both work. So, step 1. We need to check to make sure that these equations are lined up with the same order of variables. And what I mean is checking to see that the a's are right underneath each other, 3a and a, and that the b's are right underneath each other, 4b and b. If, for instance, you get an equation like you see here in the gray, where it says x plus y equals 4 on the first equation, and then 3y plus 2x equals 5, you'd want to rewrite that, making sure that you take the sign with the appropriate term. A positive 2x stays positive, and the positive 3y stays positive, so that the y's line up and the x's line up together. So this equation, that's already okay. It's done. We don't have to worry about it. Okay, step 2. The idea here is that we're going to try to add these equations together so that we can get one of the terms to cancel, to go away. So we need to think of a number that we can times either the top or the bottom equation by, so that the number in front of either the a would be negative 3, for instance, equal to 3 but opposite of sign of the first equation, or so that it would be possibly a negative 4 in front of the b, so that we have positive 4 on the top equation and negative 4 on the bottom equation. And the reason we want to do this is, if you remember, if we do addition the old-fashioned way, 2 plus 2 would be equal to 4, but 2 minus 2 would be equal to 0. They cancel each other out, so that's what we're looking to do here. So, if I take a look at this, I might notice that if I times this bottom equation by 3, times the whole thing by 3, I'll get a positive 3 on top and a positive 3 on bottom. But I need to have the opposite sign there, so I'm going to actually times it by a negative 3. So what happens when I times everything inside there by a negative 3? I'll factor it through. I'm going to get negative 3a, and negative 3 times a negative b is going to give me a positive 3b. Negative times a negative is positive. And a negative 3 times a 3 is going to give me a negative 9. So this is my new equation that I'm going to work with. So I'm actually going to rewrite these for myself. 3a plus 4b is equal to 23. And the next equation, I'll just write it underneath, 3a plus 3b equals negative 9. You don't have to rewrite them. You could just scribble out and fill in the numbers on the first equation, but I'll leave it there so that you can see the working of it. Okay. Step 3. Well, I guess that was step 3. Times it through. Okay, so we've done step 3, timesing it through. On to step 4 then. We want to actually add these equations together. So think about the old school maths, where you draw a line underneath and we say add. So we can only add like terms. So 3a plus a negative 3a goes to 0, it goes away. 4b plus 3b gives us a 7b. And 23 minus 9 gives us, in this case, 12. I mean 14. Okay. So that's adding straight down. One of our letters should cancel, which it has. And so our next step involves solving the remaining equation that we've got here. So 7b is equal to 14. That's 7 times b, so b is equal to 14 over 7, which is equal to 2. And we're going to take this equation, the statement here of b equals 2, and we're going to plug it into one of the original equations. So it doesn't matter which one we put it into, but we're just going to put it up into one of these original equations. Out of a habit, I'd probably pick the easier equation, so I'll pick the bottom equation there, as it was originally, a minus b equals 3. And now I'm actually going to replace the b with a 2. So a minus 2 is equal to 3. And the reason for that is that I've found that b is equal to 2. Using a little bit of algebra, we will, of course, solve for this. So a is equal to 3 plus 2. A is equal to 5. So now we have both of our answers. B is equal to 2 and A is equal to 5. Okay, taking a look at a second example here to do by the elimination method. So here we have 3a minus 5b equals negative 14, and 4a plus b equals 12. So we are going to look at doing the elimination method here. First thing to check, our a's and our b's are all lined up, so that's okay. Second thing that we're going to look for, what number can I times either the top or bottom equation by so that I have equal and opposite numbers on one of those letters. Now, trying to get 3 and 4 to be the same thing can be quite tricky. We'll have to times the top and the bottom by something. But I have a negative 5b on the top equation, and I have just a 1 in front of that b down below. So that's an easy one to fix. I can change the b down below into a 5. And the reason I want a positive 5 there is because I have the negative already on top. So I need to get the positive so that the negative and positive will cancel each other out. So I am actually going to times that whole equation by 5. And I have to times the whole thing, all the terms. So we will go ahead and times that 5 through to all 3 of those terms. So 5 times 4 is 20a, and 5 times 1 is going to be 5b, and 5 times 12 is going to be 60. Okay? And we still have the original top equation as it was, 3a minus 5b equals negative 14. Alright. On to step number 4. We will add, drawing a line across the like terms here. So 3a plus 20a is going to give me 23a's. Negative 5b plus 5b will give me a 0. And negative 14 plus 60 will give me a 46. And on to solving this equation. 23a is equal to 46. That's 23 times a, so my answer is 46 divided by 23, which will give me 2. A is equal to 2. So we're going to take that remaining answer, that answer we've got here, a is equal to 2, and we're going to substitute it back into one of the original equations. Now in this case, there's not really one that's easier than the other. They both have 3a or 4a, so we still have to times it by something. So just pick one. So maybe we'll pick the top equation this time. 3a minus 5b equals negative 14. And I'm going to replace the a with a 2. So 3 times 2 minus 5b equals negative 14. And here we need to solve for that b now. So 3 times 2 is 6, minus 5b equals negative 14. So minus 5b equals negative 14 minus 6, taking the plus 6 to the other side, I minus it. Minus 5b is equal to negative 20. b is equal to negative 20 divided by negative 5. I'll take the whole negative and the 5 and divide them away. So I get b is equal to 4. So those are my two answers. A is equal to 2, b is equal to 4. And that's using the elimination method.